Before a coin ever lands in your palm, it survives heat fierce enough to soften glass and forces strong enough to crush steel, then goes on to buy a bus ticket or pop a vending machine spiral. And yes, the smallest denomination costs more to produce than its face value, which says a lot about how exacting this craft really is. The journey begins with towering coils of metal, each about 1,500 feet long, roughly the length of 4 football fields. Those color differences you'd notice on the spools aren't cosmetic. They signal distinct alloy recipes destined for different coins. A coil is mounted on a motorized machine that feeds a broad ribbon of metal into the line. Even in a highly automated plant, a trained operator stands by to coax a stubborn sheet into the first machine. Once the bite is clean, the system takes over. First up is a high-speed punch that stamps smooth discs from the strip, known as blanks, planchets. Think of it as a pastry cutter, only much bigger on an industrial scale. It produces around 14,000 coins per minute, and you can hear the bins fill in a sharp, rhythmic clatter. Punching discs out of the metal ribbon leaves behind a lacy, irregular skeleton the mint calls webbing. Crews rake these jagged offcuts into bins. Then the scrap is shredded and recycled, sending usable metal back into the supply stream instead of wasting it. By this stage, each blank already has the coin's final thickness, but its diameter is still a bit off on purpose. The finishing touches and final sizing tweak, along with raising a small rim, happen later in the edge-forming, upsetting step. Next is the first of 2 extreme steps called annealing. Furnaces are brought up to temperature while nearby tanks are charged with a specialized cooling solution. The blanks ride into an oxygen-free furnace at about 1,600 degrees Fahrenheit. No oxygen means no scale or staining, even at a temperature that would ruin most household metals. The instant they leave the hot zone, the disc must be quenched, not in plain water, but in a carefully formulated bath designed to protect the surface and keep the metal from sticking together when it's most vulnerable. The quench bath isn't just water, it's formulated with citric acid, added as a powder, not from actual fruit. The acid loosens surface grime so the blanks come out clean, and it's especially important for pennies, which have zinc cores covered with about 2.5% copper on top. It removes the thin layer of copper oxide without attacking the metal itself. That's why newly made cents leave the mint with that bright, just-struck shine. The bath also includes lubricants that keep the still-hot planchets from sticking or welding together during cooling. Once they're safely cooled and separated, the blanks head to the main wash for a thorough clean before the next step. In Denver, a massive lifting scoop known as a skip basket hoists cool blanks out of the quench and into the wash line. In Philadelphia, a slow-turning whirlway tumbler does the transferring instead. Either way, the blanks run through a washer with detergents plus anti-tarnish agents to restore uniform color. Then they're dried and cued for the next station. That diameter adjustment you were promised happens in an edge raising, also known as an upsetting mill. Each blank is forced through a precisely sized groove, just narrower than its current width. The metal flows, and a subtle rim rises around the edge. It looks decorative, but it's structural. Without a proper rim, the coin can't be correctly held for the next violent step. Human inspectors spread the blanks and check them. This is the first firewall against fakes. And it matters because U.S. ports have intercepted growing volumes of counterfeit coins aimed at online buyers. In 2020, a Chicago seizure alone totaled $1.64 million in bogus coins and cash. Tight tolerances aren't just a matter of pride, they're protection. For many coins, the next step is burnishing. A tumble with cleaning agents and small metal media that smooths and brightens surfaces. Workers rinse the pieces and even hand-dry them with towels. This is the one last quiet moment before the storm. Now the real spectacle is called striking. Paired dies bring the portrait and reverse together at once, pressing detail into metal with extraordinary loads. Every day, circulating coins see around 35 to 100 metric tons, depending on denomination. Special issues like America the Beautiful 5-ounce silver pieces take a colossal 540 metric tons. Routine circulation coins, including halves and dollars, are struck once. Proofs, like American Eagles, are struck at least twice to sharpen relief and polish mirrored fields. Production is staggering. One press stamps about 750 coins a minute. With 63 presses in Philadelphia and 54 in Denver, that's roughly 47,250 coins per minute in Philly and 40,500 in Denver at full capacity. Each striking cell uses a solid metal collar that hugs the blank, seated neatly thanks to that previously raised rim. The collar prevents the metal from squirting outward under load. Without it, a coin would spread into a wide, thin disc and fail every size check that follows. Introduced around 1828, collars made coins easier to carry since it was narrower and predictable, while allowing thickness to do the work of durability. Modern dimes and quarters are 8.33% nickel and 91.67% copper, and they still run flawlessly through meters and sorters because their dimensions are tightly controlled and the alloy is precisely engineered. Newly struck coins pour along conveyors into bins, but the line doesn't run on trust alone. Inspectors periodically sample output to confirm sharp detail and correct design. If a problem shows up, the batch is diverted to a corrugating waffler, which is a machine that bends and ripples the metal so it can't be spent. Those deformed pieces are recycled, sometimes sold later as oddball collectibles. This meticulous sampling cycle is another anti-counterfeit measure. Sloppy coins mean there's a chance for exploitation. Finished coins are counted and weighed, then poured into oversized fabric bags. Once full, the bags are too heavy to move by hand, so forklifts lift and stack them on pallets. Those pallets wait in storage until the Federal Reserve places an order, sometimes after a pause, so carrying inventory is part of the process. The penny's long-term status is up in the air, yet today it still runs the full line, annealed, struck, and bagged just like the others. Walk the process backward, and each choice makes sense. High-speed blanking satisfies relentless national demand. Oxygen-free anneal at around 1600 degrees Fahrenheit strengthens the coin without discoloration. Citric acid lifts grime and removes copper oxide on scent safely. The raised rim lets the collar seat perfectly and controls metal flow during the strike. Human checks catch defects machines might miss and deter counterfeiters who look for telltale sloppiness. Collars plus tonnage forge crisp design without dimensional drift. Take away any layer and you get slower output, scarred surfaces, jammed meters, or coins that erode public trust. The redundancies aren't waste, they're guardrails. For all the robotics, you can still feel the people in this place. A specialist eases a bulky coil into the punch. Crews rake webbing like yard work in autumn. Technicians hand-dry bright planchets, the one last careful touch before the dies thunder down. Inspectors fish a sample from a glittering bin and decide whether a whole batch lives or heads to the waffle maker. The soundtrack is a cheerful cascade of blanks and the heartbeat thunk of presses doing exactly the same thing, perfectly, thousands of times a minute. It's easy to underestimate the feat here. These objects must be identical enough to satisfy machines, tough enough to take a lifetime of pockets and countertops, and distinctive enough to thwart criminals. So the Mint solves a paradox. It makes billions of tiny, identical artworks at frightening speed, yet each one has to be flawless within microns. One loose step, one bath gone wrong, one rim not fully raised, one collar misseated, and the whole dance falls apart. We began with the penny's strange economics. That little copper-tinted disc costs more to produce than it buys, which is why its future is debated. But in another way, it captures the promise of the whole system: consistency, durability, trust. Whether a penny's days are numbered or not, the process that makes it like fire, chemistry, force, and a dozen layers of quality control defines how all coins earn their right to circulate.